I'm not even going to attempt it. Okay? I'm not going to attempt that problem with fractions. I'm just not. I'm going to leave it alone. Yeah.
But I got stuck.
Sure did, right? Thank you. You just proved my point.
Yeah.
Right? So we're going to ignore the solving it with the fractions. We don't want to do that, right?
Wait, can
so
I just do that with the problem?
I'm sorry? No. No. I'm giving you a second strategy to do that. Okay? So let's start here. What is a least common denominator?
The 24 and 18, 6 would be the least common denominator, right?
Right, because it's the
Lowest
smallest
shared
number
value.
that it's the smallest number that these two numbers can also go into and be divided by, right? So it is the smallest value that all denominators can be evenly divided by. Smallest value that all denominators can be evenly divided by. So the example that Griffin gave with 18 and 24, 6 would be the least common denominator because 6 can go into 18 3 times, 6 can go into 24 4 times, right? Sometimes you only have one denominator, and so what's your least common denominator going to be? The only fraction denominator that you have, okay? So what would our least common denominator be if we're looking at 4, 2, and 6?
2. 1.
So it's the smallest number that they can all,
That would be 2.
all denominators can be even, like,
2 divided by 2. 2 divided by 2 is
maybe
1.
I didn't say that
6
right.
divided by 2 is 3. 4 divided by 2 is 2.
Denominators
2
can.
is
Okay, hold on. Erase this.
Oh, wait.
All denominators. Smallest value that all denominators can be a factor of.
Wait, what?
It is 12. It is 12. So we're looking for what can they all be a factor of, right? So they can all go into 12, right? Because 12 divided by 4 equals 3. 12 divided by 2 equals 6. 12 divided by 6 equals 2.
Common denominator, right? Not least common.
This is okay.
So this is the least common denominator, meaning the smallest value that all of those denominators can be a factor of. So because 6 can go into 24, right? And
But
yeah.
then it would just be.
I think it's different.
Oh, that makes sense.
I think.
Right,
the
so like-
I don't think 24 because.
Okay, we're moving on. I think we all understand where we're going with this, right? 12 is the answer. Okay, is everybody with me? Everybody see? We're all on the same page now. Okay, so we're going to take each of these, right? It says multiply each of the fractions above by the least common denominator. So we're going to take 3/4 times 12. We're going to take 1/2 times 12. And we're going to take 5/6 times 12. So you guys all know the trick, right? For multiplying a fraction times a whole number?
You have to put the 1 under the 12.
3 times 12 divided by 4. 3 times 12 divided by 4. 9. 1 times 12 divided by 2. 5 times 12 divided by 6. 10. Okay, so by multiplying each of these fractions by the same least common denominator, we end up with nice, more manageable, easier to use whole numbers. Is everybody with me?
Can't you put in
Yeah, what do
one
you use the
under?
whole numbers for?
You
Can't
could,
you-
but then you have to multiply, and it's just the
Can't
same
you
thing.
put a 1 under the 12 and then just
It's the same thing.
multiply it out?
Yeah, you're still multiplying across, you still get 36 over 4, which is 9. We're not there yet.
Okay.
Okay.
Ben!
You dropped your crutches. Yeah.
I think we're good.
I'm glad you weren't.
Okay, so now we're going to use this information to solve this equation by getting rid of our fractions, because we're going to multiply each term by the least common denominator. Now, this is where it gets a little hectic because we have some terms that are not fractions. If we're going to do this, everything needs to be multiplied by the least common denominator. So we're going to write out this equation, 3/4 x plus 1/2 equals 5/6 x minus 1. We're going to rewrite it. Then we're going to use our distributive property. Everything's going to get multiplied times 12. Even this 1 over here is going to get multiplied by the 12. Everything. So when I distribute that, 12 times 3/4 is 9. So now I have 9x. What's 12 times 1/2? Plus 6. 12 times 5/6 plus equals 10x. 12 times -1? Minus 12. Now I have this very easy to solve equation with no fractions, right? So the first step is find your least common denominator, multiply everything by that, and then you get your nice whole number, coefficients, constants, and you can solve. So then I would subtract 9x, because remember yesterday we talked about staying away from those negatives. So now I have 6 equals x minus 12. Then I'm going to add 12 to both sides. $18 equals x. Right? Significantly easier than finding common denominators so that you can add and subtract the like terms and then remembering how to divide. Right? So it takes a little bit of work here, but then it's like super fast and you will be accurate. So let's turn this over and look at the next side. We're going to skip this. I think we all know why it's easier.
I prefer the 1/9. Yeah. Yeah.
So here's what happens when you do that. What's 5 divided by 6? What's 5/6 as a decimal?
I don't know off the top of my head.
I'll give you a hint. It's repeating.
Okay.
So how do you solve a problem with a repeating decimal? How do you get an accurate answer if your decimal's repeating?
You don't.
You just see your way through.
You still get an
You like
answer.
turning arguments just for reasons.
It's not going to be accurate. Okay,
What about ones that have like?
Griffin, stop. Griffin, just stop.
we're moving on.
When's the last time you won?
You can listen. You can do decimals. That's fine, but you're not going to have the right answer. So if you have repeating decimals, it's going to be incorrect. I would rather you use this strategy so you can get all your points, because I know you understand the math, right? I think you do. Okay. So right here we have an equation with decimals. Now, these are terminating decimals. You could keep them and do the whole problem with decimals if you wanted to, or you can clear the decimals by multiplying each of these values by a multiple of 10, right? So if I multiplied 1.5 times 10, what am I going to get?
15.
15. It would just move the decimal one place. If I multiplied 2.55 by 100, what would I get? 255. So for that, all I need to do is see, okay, I have 2 decimal places here, 2 decimal places here. So I'm going to multiply all of these by 100.
And then divide by 100.
So 115
And then
plus.
I'll just have my answer will be that number. So let's look at it. So we're going to multiply. Let's write another nope here. We're not doing that.
No,
Nope.
On that one, right?
don't worry about it.
All terms by a multiple of 10. So depending on how many decimal places there are, that's what your multiple of 10 would be. If there were 3 decimal places, what would I multiply everything by? 1,000, right? Because I need it to shift 3 places. Okay. So what this is going to look like is 1.5x plus 2.55 equals 0.75x minus 1.95. All of these are going to get multiplied by 100. All of the terms get multiplied by 100.
You get
Would
no
you get a negative
solution.
number? 7.
So we're going to have 150x plus 255, because I'm just shifting the decimals 2 places. 75x minus 195. Go ahead and solve that by yourself. You guys should be able to do this. Variables on both sides. We've got our wall of equality.
Silly goose. Would you get a negative number for that?
Hmm?
Yeah. Okay.
You can use a calculator if you need to.
It's 2. No, it's not. It is. Negative 6. How is it negative? Can I see your picture? No.
You get 450, okay? 450, okay? 450 divided by 225.
Oh, I see. You're rewriting. So I subtracted the 75 to stay away from a negative number because we don't like the negative x's. And I swerved that over. 150x divided by 75x equals 75x. Plus 250, which is not x, equals negative 195 because that's negative. Then I subtract 255 to negative 450, and then I divide 75 by this.
So I would both have 2 different answers, but solve it correctly.
Yeah, we both did it.
Yes. Because it's relative.
I don't know, maybe you like put subtracted like on both sides. But you didn't do anything mathematically.
I subtracted the No, I was subtracting the,
Because you see how the 2.55 is
Yeah,
yeah,
subtracting the
so it's actually by however many decimal places.
Why'd you subtract it?
So if it was only 2.5, 7.5, and 1.9, then you can do 10. Because you don't need the 2.5.
Well, I subtracted
Okay,
75.
let's check our answers. See how we did.
You got a different answer because you just subtracted. You subtracted 150 instead of 75.
Okay, well, and if he, so that's okay. So again, it's kind of that's when we talked about choose your own adventure. But you just have to remember I mean,
well, we
hopefully,
both got two different answers.
right. So we'll figure it out.
Nothing mathematical. So yeah.
Okay, so I subtracted the 75, and then I was left with 75x plus 255 equals negative 175. Then I subtracted this. Are you okay? Do you need to go get a drink? It's okay if you do. Did you choke on the Jolly Rancher? Ben, are you okay? Sure? No, we're good. Okay.
I think Ben has the virus.
We're going to try to get through this. Okay? So then we're left with this 255, which I subtracted. And then I end up with 75x equals negative 450. And then when I divide by 75, I get negative 6. Okay, now, if you had subtracted over here first, then you would end up with negative 75x on this side. And then you would add this over here, you're going to end up with positive 450. You're still going to get negative 6 as your answer. So that's where the choose your own adventure comes in. You still would have ended up with x equals negative 6.
Yep, I see what it
Okay. All right, you have about 8 minutes. We're gonna stop right here because this one is another layer of intricate decision making. Okay. Yep, put this in the back of your semester 1.